and welcome to the Red Hat Forum. My name is Ian Hood, Chief Strategist, Global Industries at Red Hat. And certainly hope you're enjoying these hybrid cloud breakout sessions, and really wish that I could be there in person to join you and engage in this conversation, but look forward to your questions to our teams. And why don't we get started? So this session is really about being a look at the edge, and what are the operators doing with their Telco 5G investments, and how they're looking at deploying services on top of that highway in many industries. But before we kind of look into the technology, we kind of, obviously got to take a look at what's the opportunity. So the opportunity, by the analysts that you see here, is growing quite quickly, almost 30%. And it's going to be in the area of 160 billion by the time we hit 2025. Now, this is the market size for the services being delivered to those industries. Now, if I go look at it just from the service provider perspective, across this collective of industries, from manufacturing, healthcare, agriculture, aerospace, logistics, the opportunity for them is roughly 33 billion out of that larger number, roughly 20-ish% of the opportunity. So quite a large opportunity to capitalize on this new wave, if you will, of bringing data closer to where the operations are happening in the industry and actually acting on that data and delivering better services, better capabilities within those industries. Now, if I step back and take a look at it from the industry perspective, we've sort of taken a snapshot, if you will, of what are they going to do in terms of how they're going to consume the edge, who they're going to actually buy this from. And you can see it kind of varies with each of the different industries, from manufacturing across to healthcare, et cetera, that, from the mobile operators, the tech vendors, the system integrators are always a really strong player. But certainly now, as the public cloud players are looking at delivering their edge services and different capabilities, there's certainly a large interest by many industries in partnering with them to consume edge services, either on-prem through them or directly at one of their premises. Now, in terms of where we are at a high level across the industry, it's already happening. All right, we already know that from a telco perspective, the mobile operators have already started deploying their 5G, and it's a distributed course. That's edge computing distributed. The UPFs are moved across that way. The radio access networks, same thing. I'm going to use edge computing for highly distributed radio access networks with Open RAN. And so this is really already in full swing, and it's really kind of, if you will, the year of the RAN and distributed 5G. Now, across other industries, now that we've got this next generation network from a mobile perspective available, it's about taking that set of technologies and delivering services to oil and gas, by being able to control the big heavy equipment they've got, use video to look at safety situations from fire on oil rigs, to inside the R&D capabilities of the automotive industry, as well as at the test tracks and how they develop new vehicles, the in-vehicle application capabilities, as well across the agriculture industry in terms of being able to increase their yields, reduce disease, improve overall safety. So these things are all capable by the fact that we now have compute capabilities brought closer to where that data actually starts, that we can actually deliver these better capabilities, better services, and improve things in general for the economy. Now, in terms of how you can actually deploy this on top of Red Hat platforms, it's really about looking at it from today where we started and have been for quite some time, being able to deploy OpenShift in the data center for the applications portion, as well as for the data portion. But as you move across, to the left of this diagram, to the edge, you've got, again, potential for large clusters. Some customers still at the edge have very large clusters of nodes in that category. But there's also, if I want to have many more sites and just have a certain amount of compute nodes, I've got a 3-node cluster option that's an HA capability. But as you move further and further to the edge, you want to have less overhead in terms of the technology. So we can actually span and expand that edge capability out to the remote worker node and actually have X amount of CPU capability for those applications at the far edge, as well as using single node servers. And we're seeing this in the RAN applications, we're seeing this in the point of sale applications, we're seeing this in many of the edge industry use cases. Now, one of the other capabilities, not in the OpenShift category, is the ability to use a really small footprint, a router edge, small node, a few CPUs, smaller amounts of memory to deliver very specific applications in different industries with that footprint much smaller, but still being able to be controlled by the same management tools now that we have, both from a Red Hat Advanced Cluster Management perspective, as well as Ansible automation and Podman. So this gives you kind of a lot of flexibility. Depending on what your use cases are, you can use any one of these configurations and capabilities to build a very scalable set of services at any industry. Now, in terms of what that picture looks like in kind of a different version of it, is if we take that same picture and say, here's the telco network, where's the enterprise edge live, right? The bottom half of this picture is the telco network, and it spans from the operations center to the core that we've been building both in LTE and in 5G. Right? All these things now are running on top of OpenShift at our customers. That's kind of where they're going. And now as they go and look at trying to deliver edge services, they want to deploy those for multi-tenancy at their provider edge location. And so that's kind of right in the middle left of the diagram. Before you get out to the radio access network, we're doing those now as well, but that's really more for your macro network for all of our handsets that we use. But that's the Open RAN movement that's been going on and quite strong right now. Now, if we look up into the top left of this diagram, this is where you start to see the on-premise enterprise edge, where the customer wants to keep the data on site, massage and manage it there, and do that from his industry perspective at the factory, at a distribution center, and that's really where private 5G comes in, and that's a potentially delivered by an integrator, by the telco, but they could also partner with one of the hyperscalers to use any of their edge capabilities as an option for the enterprise edge. Now, I mentioned before that the device edge, that's where the RHEL for edge comes in, a much smaller footprint for industrial IoT, controllers, so video applications, facial recognition, those kind of things are really the far edge or device edge portions. What we can't forget, though, is that this whole picture really still has to tie back to the existing platforms in the data centers and public clouds. The different applications, whether it's IoT, analytics, the existing back office in the telco, but there's also the data platform. We actually have the centralized data. We collected some of that data from those edge sites, and we're now massaging that, not in real-time management, but this is where we do a lot more of the data science and data management, is on that location on a data platform. And then, of course, there's required storage in data lakes as part of this end-to-end architecture. So very simple picture, but we all know it's quite complicated. And as I say, this is really how we put together an entire horizontal platform approach to delivering edge services on top of the telco 5G highways. Now, I mentioned before that the customers, the end customers, the enterprises themselves, they may choose different ways that they want to actually go consume this. So one is that they can actually go to the telco, go to the operators like yourselves, and actually consume this as a managed service. Same way that they consumed a managed IP VPN service before. This is now an edge application managed service that the telco owns and operates. Now, of course, some customers say, you know what, I'm gonna go build this myself. That's an option. And they may choose to go take this as a package and say, this is kind of a solution that I want to go build, and I'm going to do that myself. That's down in the middle here. The other option, of course, very much in vogue for quite some time in many industries, is that the system integrators are the ones that are actually going to own and in some cases operate this. And both the public cloud players and the integrators have this option, and they may own and operate portions of this, right? Not the whole thing, right? As you saw in the previous one, was a fully end-to-end solution on the bottom, but this one's actually a portion owned by the integrator or the cloud provider, and some of the other pieces deployed separately by the customer. So kind of a mix and match hybrid approach. And we're seeing all these variations in play with all the different partnerships from the telcos with the hyperscalers, as well as with the system integrators, and some of them are actually partnering with the hyperscalers as well. Now, one of the things that we wanted to take a look at was, okay, so what are the economics, right? So when we take a look at this, we work with a partner, and we came up with a business architecture model for the entire end-to-end system. The telco cloud layer, all the things we're used to, the capabilities of the servers, the network, the storage. Then you put on top of that, the radio access network, the 5G core, the MEC capabilities, and add on up this stack to actually provide the necessary applications to deliver these tools and capabilities. So the AIML, data management, analytics, those kinds of capabilities have to be layered on top. And then the actual end applications layer for factories, logistics, robots, drones, guided vehicles, all these different things on those applications necessary to deliver the end-to-end edge service on top of that telco cloud. And so what we did was we took this entire picture, look at the economics of it from a cost perspective, but also from a revenue perspective. What revenue could I get from an end enterprise in manufacturing, healthcare, et cetera, and what would that look like? And so what we came up with was, if we took a distributed 5G core, put a number of tenants on it, 3 different types of them, built up a number of sites to deliver these applications, both the edge and regional data centers included, looked at many enterprise applications, from AR, VR, IoT, video applications, included the broadband services, some real-time capabilities, and looked at what would it be in terms of economics, and sort of what are the estimated revenues you would get from those services. And we compared 3 different ways to do this. And the first way is sort of a do-it-yourself. That's the multi-access edge compute telco cloud option. That's the first one. That's the yellow one on the picture. And then we also looked at it in terms of consuming it from the IBM cloud or IBM satellite, as well as comparing sort of the other hyperscalers, AWS, Google, and Azure. And what we found is that the real key thing here is that for all 3 of them, right, the payback in all cases was roughly 18 to 24 months. So a pretty good turnaround. And in terms of the actual overall costs, regarding, these graphs are fairly close to each other. So the delta between these different options is really quite similar, 5 to 10% difference between them. And really what it comes down to is, do you have the people yourself to actually manage this service, or do you want to hand some of that to somebody else? And do you want to consume it more as a managed service, from a hyperscaler? Or do you actually want to, build it and deliver it yourself and have total control? So that's really kind of the difference here in terms of your operational model, but there are choices. And what we're seeing in the industry is that many of the customers, many operators, are picking multiple partners, integrators and hyperscalers, to deliver different types of edge services depending upon their needs. So we're kind of seeing a very hybrid approach in what's going on in the marketplace. So I just wanted to kind of stop for a moment and think about the next piece of this puzzle, which is, okay, so we've looked at the technology, we looked at the economics. Now the question is, where are we seeing this happening in real life? Where are we actually getting some of these capabilities delivered by different customers, different industries, and that's sort of the next picture, if you will. We'll kind of move on to that, and that's sort of the industry momentum side of this thing. Because people have been talking about this for quite some time, trying to figure out what use cases they want, where they want to focus on, what industry, and I've got just a few examples, but it really spans many industries. And we'll start with automotive. So here's one in which we're partnering with one of the automotive manufacturers to help them build their next generation of self-driving vehicles. So what you see here is a full closed-loop automation, if you will, of from the sensors to the data to the way it's ingested, and actually applying machine learning to it, and actually a full circle across this. And the next one is really the over-the-air updates for the in-car systems, right? Same sort of a flow from the edge back to the center, where we take our technologies, use PodMan at the very far edge, use our middleware to actually provide the telemetry back to the edge sites, and all the way back to the IT and business systems, right? So a end-to-end pickup we've done with a partner called eSync to deliver this and a much better experience for those of us driving that vehicle. Next up is in the area of facial recognition for commercial payments and fraud detection. What we found there is that the operators really improved their latency, almost by a factor of 5. And they built this on top of those MEC sites with the right gateway functions and capabilities on a horizontal cloud platform, all the way through their central site to where they actually do the accounting and control of it, and back onto their to their IMS core. Now, one of the very interesting areas in the industry these days is taking place, and that's the use of digital twins, whether it's in mobile towers, as you see on this picture here, where they're using it to actually control how they build towers and actually take care of that very high expense. Same things happening in many manufacturing areas, automotive, aerospace. Very interesting one, of course, is in healthcare, whether it's the CT scanners, the Medtronic type devices for monitoring your heart or your lungs or your brain. All these things are being replicated in digital form, and that whole system is something that you want to actually use edge computing for, to control that information and spread it around to multiple locations, and take care of that data integrated in place where it is, to keep it secure and have much faster response time. Now, in terms of the healthcare, as I just mentioned, the hospitals have really been doing a lot of work in taking advantage of image analysis and sharing that information so that they can actually compute and compare many images in minutes, compared to how much time a physician takes to look at just one of them. Right? So they actually take this information and they share it back and forth in a secure manner, encrypted between the hospitals and the different locations. And only the data that is relevant, which is the video imagery of the brain in this case, is being actually shared back and forth. And it really does allow them to give much better and targeted therapy to the patients. Really kind of a very exciting place. Now, one of the other evolutions of this particular use case now is a research project going on, again with the same consortium actually, of the Boston Children's Hospital, Darwin AI, University of Waterloo, as well as Red Hat. And what they're doing is taking chest x-rays from 25 different countries, and they're looking at those and scanning those to improve how we target and improve patient care for COVID. Right. So this is another one that has really taken off in terms of taking advantage of the technology and sharing that information globally in this case, to actually improve how we handle that virus and improve the recovery from it. And this just is another picture of kind of the healthcare space of, if we distribute this sets of functionality, you can have the VR cameras, the digital twins, the social bots, the drones, and these can actually be handled and delivered through an edge site, and that information can be done and collected with analytics right at those initial sites, and some of the data then passes on up to the central site for more telemetry, and builds that end-to-end picture for that healthcare use case. Right, so really, solving for public safety, patient care, improved response times, actually targeted therapies, and including sort of speech to text and social robots. Those are also other things we're seeing in the industry. Another area that's really quite interesting is whether it's in transportation, in this case it's in shipping, and the logistics of a large port. So we partnered with Lenovo in Dubai, and this is really about managing traffic through the port, as well as all the assets, all these containers, and using augmented reality to kind of have better visibility to it, automating the cranes, and also monitoring compliance from a security perspective. Right, so a very exciting case that's in flight already today. And just to kind of sort of wrap up the collection here, I won't go through all of these, but some of them here are in agriculture, and as well in, already talked about remote heavy equipment controls. There's grid power systems. We talked about automotive, car configurators, the venues. Many venues are being utilized today for delivering better experiences in all types of sports, whether it's American football, the FIFA Cup European football, as well as golf tournaments, racing, F1 as well as Daytona, and even things like virtual film production, where I've got actors and crews in different countries, and we're handling this remotely. And of course, one of the situations we have right now here in the West Coast, where I live in the United States, is that fighting fires in British Columbia, Washington State, where I'm in, as well as Oregon and California, taking advantage of technology to improve that environment and safety for the first responders that are actually working hard to actually control the fires we had this year. Same thing has gone on actually in Australia. So some very interesting use cases happening around the world. Red Hat's involved in them, our partners are involved in them, and really quite a lot of excitement about how we can actually use edge computing and 5G technologies across any industry. Now, how do we actually sort of make that happen from an industry perspective within each company? Well, it's really kind of a matter of survival, right? And it's about changing your entire business. And this whole digital economy is sort of a new way of doing things. And kind of the key things that I've seen in working with our customers, and many of them have actually been successful, have actually followed kind of the 4 things that are on this page, which is number 1, they can't do it by themselves. They found strategic partners to integrate things, and that's really key to the success, right? Now, in terms of when they go after delivering services, they go and establish kind of a small beachhead, be it in healthcare, be it in manufacturing, be it in automotive, and go after that and deliver and demonstrate success, and then they can go replicate that for another industry. But a couple of other things that are important is that because many of our customers have different lines of business, from the business services side to the mobile side, the operations side, the team has to be empowered by the executive leaders, right? And that's really important. And have the right governance to actually let them go be successful in delivering these services. And it really is going to turn everybody's business upside down. It's happening in all markets, not just in telco, because the competitive pressures to become much more of a digital service and software provider is really changing how things are done. And just a couple of examples of customers who have been successful already with us. People like Lockheed, they completely changed how they do things. So they changed the culture, they changed the tool chain, and they can actually make changes today on the ground that are actually in the software on the plane the next day. Same thing's happening in the financial industry. I picked a bank in Australia, and they basically can change any product anytime, and it doesn't impact their customers. Really gone completely digital in how they approach things. And with that, I appreciate you taking the time, and thank you for listening, and hopefully you found this session interesting and informative.